Hello everyone, welcome to the solution of LeetCode problem 310 named minimum height trees. In this problem, a tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycles is a tree. Now, given a tree of n nodes labeled from 0 to n minus 1 and an array of n minus 1 named edges where edges of I is equal to A of I and B of I indicates that there is an undirected edge between the nodes AI and BI in the tree. Now, you can choose any nodes of the tree as a root. When you select a node X as a root, the resultant tree has height h. Among all possible rooted trees, those with minimum heights are called the minimum height trees, which is MHT. Now, we have to return a list of all minimum height trees roots level. Now you can return the answer in any orders, and here the height of the rooted tree is the number of edges on the longest downwards path between the root and the leaf. So let's consider this example. 0 is connected to 1, 1 is connected to 2 and 3. Now here, if we make the node 1 as the root of the tree, the height will always be 1. Because for the first scenario, the height is 1. For the second scenario here, the height is also 1. And for the third and fourth scenario, the height is 1 as well. So here the minimum height is 1. So the root is 1. So we have to return 1. Now, into these scenarios, we have seen that if the root is 3, the height of the tree is 2, which is 3, 4, and 4, 5. And if the root is 4, the height is 2 again, which is 4, 3, and 3, 0. So here, if we make 3 and 4 as the root, the height will be minimum. So we have to return 3 and 4. I hope you understood the problem statement. Now let's move on to the algorithm. In this algorithm, we are using the topological sort, and to implement the topological sort, we will use the Kahn's algorithm to solve this problem. So here, what is the first intuition comes into our mind? The first intuition is that at first, we have to find the longest path from any node to any other node into the given graph or the given tree. And the center node of this longest graph will be the root. And if we make the center node of this longest path as the root of the tree, the height of the tree will be minimum as possible. Suppose if we make this 9 as the root of the tree, so here the height will be this long path, which is the maximum. But if we make the root 3, the height will be the minimum, which is which is only 3. So the first intuition is that we have to find the longest path into the tree, and we have to determine the center nodes. So here, if we make the center node as the height of the resultant tree, if we make the center node as the root of the resultant tree, the height will be the minimum. So this tree will be converted into the minimum height tree. Now the question is, how can we implement the algorithm? We can easily implement the algorithm using the topological sort. Here, in the topological sort, at first we have to get all of the node or discard all of the node which has in degree 1. So here, the node 1, 2, 9, and 10 has the in degree 1. So we have to remove it along with the edges. Now, after removing the node has the in degree 1, the tree is become something like this. Now here, the node 6 and 8 has the in degree 1, so we will remove it and the tree will look something like this. Now, these two nodes 4 and 5 has in degree 1 and the tree will look something like this. Now, this is the final iteration. And here we have remained only one node which is equal to the 3. That means it will be the respective root of the minimum height trees, which is this node. And finally, we have to return these 3. I hope you understood the algorithm and how we have used the topological sort to solve this problem. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named find minimum height trees, which has integer n in the list of edges. Now, if n is equal to 1, we have to return 0. It is the simple corner case. Now, we are taking a result vector and in degree vector, and we are taking adjacency list and the cube. Now, for each of the edges, we are building the adjacency list and increment the in degree of both of the x and y. Now, for each of the node, here, if any of the node has in degree of 1, we have to insert it into the cube. Because to implement the topological sort, we are using the BFS. Now, into this BFS, while the queue is not empty, we have to clear the current result vector and calculate the size of the queue, which is the current level size. Now, for each of the size, we have to store the front element of the queue into a variable cur current, and we have to remove it from the queue and insert the front element of the queue into the resultant vector. Now, for each of the child in the adjacency list of current, we have to decrement the in degree of the child, and if in degree of child is equal to 1, we have to insert them into the queue for the next iteration. Finally, this loop will be over and queue will become empty for the last level, and this outer loop will not be executed because the queue will become empty till now. So the result will not be clear. So we have to return the last result, which is the list of the roots of our tree if we want to make the tree as the minimum height tree. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.